All right, so put your phone away, and then we're gonna start doing stuff. This test happened to be pretty important test, and so I'm gonna choose to go over it right now because I want ideally I want to finish before spring break, and I just realized I have stupid connectivity day on the March 12th.
She thinks it's the most brilliant idea she's ever thought of.
Who? Wait, who said they're gonna stop?
Every day you teach, every year you teach, you're gonna have more connectivity days.
I'm quitting tomorrow. I'm quitting tomorrow so I don't have to face the next connectivity day.
Brilliant idea ever. You get on like these meetings with her, and she's like, "Oh, does everybody love an activity day? We're seeing such a positive outcome from them." Like, no, everybody hates them. They're only positive because nobody shows up to school, so everybody's not they can sleep in.
Are you talking about an FCC meeting?
No, this is from the superintendent. When I get up meeting with her,
Why do you have to get a meeting with the superintendent?
the student body president.
Oh. Did you tell them that you hate it?
I get yelled at.
Who?
I just said that we've seen a decrease in attendance, and she didn't say anything.
Yeah. We're gonna rebel to it.
We,
I mean,
I'm out of here, Jim.
I gonna.
I don't have to go to school anymore.
All right, so what we're gonna do is we're gonna do ratio test. But do you remember that in your test there was a question looks like something similar like this? Something like along the line like this. 8 to the 6 minus 16 to the 24 plus
So why would you give us a question we didn't know how to do?
you do know how to do this. I'm show you. I'm show you why you do know how to do this and how similar this to a ratio test. I'm gonna show you the comparison. So 32 over 120. I have a headache, so yeah, if you mess with me, I might curse you off. So I don't want to do that. All right. So now I have the questions, and then what we're gonna do is talk about Aiden. What we're gonna talk about is why is this question can be done without ratio test, and it will be much easier with the ratio test. Okay, so first of all, we know that this is alternating because it has a plus minus and it's pretty consistent. And we also can write out the sequence or series, which is n equal to 1 infinity, and this seems like it's -1 to the n plus 1 times a to the n 2 to the n over n factorial. So this is something that we know of. So we know it's alternating. So that's why it's, and now we gotta do is limit as n approach infinity of 2 to the n over n factorial. Now we know that this is gonna go 0 because of the bottom and top is gonna be at different rate, even though
Text yesterday, just like basically that, saying that we know it's.
that's fine.
Okay. Because I couldn't figure out how to prove it because I didn't want to do.
Right.
Hospital, just wasn't.
Yeah, because you cannot because you know that ideally by now you should know that 2 to the n does not increase as fast as n factorial, and if you write down equal to 0, it's fine. Now the third one, yes, they don't care.
It's fun.
AP exam they're gonna be like, is this follow series converge or diverge? So I mean,
Even on FRQ,
FRQ they will, but they won't give you something like this. They will give you like alternative harmonic usually, or harmonic. They won't give you something that's like this difficult. Yes.
Would they give you? How would they give you converge or diverge on multiple choice?
They will say absolute converge, or they will say
There's only 3 options.
I have headache. I cannot talk while you guys are talking, especially Armin that table. I don't know. You guys have conversation. I cannot talk over you guys because I will curse one of you guys off, and I'll get reported, and then I don't know. I'm gonna tell you that right now. Like I will curse you off, and I don't want to, because my head is like pounding. I have a 800 milligram ibuprofen right in front of me, and I'm thinking about whether I should take it or not.
You should probably take that.
Yeah. So, but it will help me if I don't hear the conversation, or you have conversation, just raise your hand and talk to me, because this is not the day I will want to be messed with. So the third one is decreasing. Now decreasing, we can take a derivative, and obviously we don't know how to take a derivative of that. So this is a thing that you supposed done at a test, was taking a to the n plus 1 is less than a to the n. And then you had to move it to the other side, divided by a to the n on both sides. So it'd be a to the n plus 1 over a to the n is less than 1. Now, why is this important? Because this is important that we're gonna have to deal with is, okay, well, this is sort of a introduction of ratio tests, and it's a very, very similar. You're gonna look at this test, it's gonna be similar to the ratio test, and the ratio test is kind of be a lot more efficient than this. But what we're gonna do is we're gonna plug in, we only worry about the series, so we're gonna say limit as n approach infinity to the 2n plus 1 over, actually we don't even need to do limits really. We can just do 2n plus 1 over n plus 1 factorial, and we can divide it by 2 to the n over n factorial. This is equal to 2 to the n plus 1 over n plus 1 factorial times n factorial over 2 to the n. Keep change flip. Now this is the part that you need to know, is you can break this up to 2 to the n times 2. Is that okay? Over n plus 1 times n factorial. Because I changed that to the factorial, and so I can cancel out with the n factorial on the next term and 2n here. Now if I cancel like this, right? If I cancel like this, and you're gonna get 2 over n plus 1. Now we say this has to be less than 1. Or less than equal to 1, sorry. So you think about it, when n is equal to 1, then it's gonna be 1 less than equal to 1. If when n equal to 2, it's gonna be 2 less than 3. And in the future, it's always true. So this is always true. So therefore, it's decreasing. So therefore, alternative series says, AST says is converge. Okay. So that is this particular question that you did on the yesterday's test. Yes.
So we could in yesterday's test like point out the thing and say it's always decreasing.
We will talk about that when we're grading it. Ideally is I want to see you, this is something I went over on the homework and on the notes as well. So to test decreasing, this is the second way. Now there's actually probably like 3 ways. Is first of all using derivative. Second is using this a to the n plus 1 less than a to the n. Technically, that's one way. If you divide by an both sides, that's actually counts like 2b and 2a. The second way like first option, the second way, second way, first option, second way, second option, option A and B. So those are actually two options in this case. In this case, we're using the second option, which is much easier to compare an plus 1 less than an for most of the cases. But this is the cases that I have to divide it over. That would gets more complicated. But I did including on the notes. I did write on the side of the board. I don't know if you guys remember. I erased it. But that's one thing that you should have done. Now AST says converge in this case. So then what's the difference between ratio test and this test? This ratio test is a lot more efficient because it takes away a lot of things, because here we're going to talk about what is a ratio test. So this is the things that we're going to do today, and it's very, very easy. So we say let summation of a to the n be a series with non-zero term. And the first option is as the series summation of a to the n converge absolutely when, here's the thing that you're going to see some similarity to it, n is greater than 1 of a to the n plus 1 over a to the n, and is less than 1. Does that look like familiar? Yeah. It's just a to the n over a to the n less than 1, but this time we put absolute value. Why do we put absolute value? Because we take an account into alternating series. But this does not have to apply only in alternative series. It can apply to both alternating or non-alternating, because this one's converge absolutely, and this is one of the things that you can see that absolute value comes in play and take away the alternating part. Second thing is the series summation of a to the n diverge when limits n approach infinity. In two situations though, an plus 1 over a to the n is greater than 1, or limit n approach infinity to the a to the n plus 1 over a to the n is equal to infinity. So either case is going to be a diverge situation. Now let's just think about it, why that is, right? This is just telling me is decreasing. If it's decreasing, has to be converge, because this is basically we have an plus 1 less than 1 less than a to the n, and you divide by an both sides, and that's why you got an plus 1 over an is less than 1. That's why it's less than 1. It just means decreasing. Now if I absolute value of this sequence and is less than 1, that means the function is decreasing, and also take account into absolute value, which is a harder condition. So which is converge absolutely. And if it's greater than 1, it's diverge, because the number, if it's greater than 1, that means the number is going to go up, right? If it's go up, it's increasing. When something's increasing, it's always diverge, because you're adding up all the term. Or if it's infinite, then that's even worse. So this is the two conditions for sure diverge. Now, can it be equal to 1? Yes, of course. The series summation of a to the n is inconclusive. So inconclusive, if you had to go back to alternative series tests or other direct comparison tests, probably. If limits of n approach infinity of a to the n plus 1 over a to the n is equal to 1. So they can be inconclusive. Is any questions here? So now we're just gonna have to try a question. Okay, so We already did the 2 to n factorial, so we don't need to do that one. Yes.
How would that question work? The question for the test. For like n equals 1.
Yeah, so the question on this one is make it a lot easier. So you're gonna get so what happened is just absolute value it. So you don't even need to do alternating. That's a great question. Is it -1 to the n plus 1? Actually, it's gonna be n plus 2. Why is n plus 2? Because n plus 1, right? Times 2 to the n plus 1 over n plus 1 factorial, all over -1 to the n times 2 to the n over n factorial, an absolute value that limits as n approach infinity. Is this okay? Now, what's nice thing is this: they just, when it's absolute value, this completely go away. So this becomes the same question as this, right? And that will become less than 1. Because in this case, it's going to be less than 1.
Would you put less than 1 after n equals 1? Because n equals 1 when it's 1.
Yeah.
Isn't it n plus 1 on the bottom?
Well, actually, hold on a second. I might have made some mistakes here. This one is gonna be able to 2. Well, in this case, n is equal to 1, so it's gonna go 1 and keep on going. But usually the case I'm gonna give it to you is probably start at 0. If it's the situation, if it's a ratio test, I will give you a start at 0. So you don't have that same issue. So I won't give you a question that you have that issue. So now what we're gonna do is we're gonna say, okay, I want you to try to do this one, summation of n equal to 0. So we're gonna start at 0, infinity, and 9 to the n over n to the 5th. So what do you think? Is this series converge or diverge?
You said it doesn't have to be alternating.
What?
You said it doesn't have to be alternating or
No, ratio test can be alternating or non-alternating, but it's alternating, they just take the -1 away, which is that's why you do absolute value. Good. Top 5 finish? Not yet. We wait for you.
I'm sorry?
We wait for you.
Well, of course yourself.
Then you finish.
No.
Nearly. Luke. Ethan. Ashton. Okay, so what we're gonna start is we're gonna go over it and really quickly. So again, we're gonna do absolute value of n approach infinity of 9 to the n plus 1 over n plus 1 to the 5th all over 9 to the n over n to the 5. And this is the absolute value. So that is going to give you limit n approaching infinity of 9 to n plus 1. But instead of n plus 1, I'm going to write down as 9n times 9 over n plus 1 to the 5th times n to the 5th over 9 to the n. And this is absolute value, so you don't need absolute value anymore because they are positive. So this can cancel out. So that's equal to limit n approach infinity of 9 times n to the 5th over n plus 1 to the 5th. Now here's the exponent rule a lot of people don't understand. So if they both have 5th power, can you just put it underneath one thing? So technically you see that a lot before, like say square root a over square root b. That's just going to be square root ab. Does that make sense? This is 1/2 power. So technically you can apply that same thing, so it'll be n over n plus 1. Now when n approaches infinity, that's going to be equal to 9 because this one's going to give me 1. 1 to the 5th power is 1, so this is 9. And 9 is greater than 1, so therefore it's diverge. Is that okay? Okay.
Can you spell it, please?
Next question I'm going to give it to you is n equal to 0. Infinity n square times 2 to the n plus 1 over 3 to the n. Now, a lot of times it's like people knowing it's like when do we use ratio tests? Which is situation you think you should use ratio tests? Yes.
Can you use it here because you said if the condition, one of the conditions was let a of n be a series with a non-zero term, the first term in the series is 0. Is it not? Because n is equal to 0. So the first term, if you plug it in to 0 squared, the whole thing's going to go to 0, would it not?
You're talking about non-zeros term is in this case, if you plug in 0, you're gonna get 0. That's fine. You still can continuous going on to the future term. Not all the term is 0.
So what is
It's just only the first term is 0.
So then what does the test mean? Let a of n be a series with a non-zero term? Just what you wrote down for the ratio test.
Right.
So what is like what would one that is like,
Valid question. Hold on a second. Let me see if I can find an answer to that. What I'm thinking about their non-zero term is not all the. It's like just make sure it's not summation of zeros. Yeah, that's what I was thinking. But why do they say had to be non-zero? It doesn't stress that. Hold on a second. Let me see. I'll get back to you on that. I'm gonna research it what happened. But yeah, you're right about that. But in this case, yes, you can use the ratio test. So let's pretend that you can and see what happened. By the way, oops, shit. My brain doesn't even work. I keep on typing the wrong password. Okay, so for this case, if you got done, you can go to the next question if you think. And we also talked about this one in the past before. N to the n over n factorial. Now, I'm going to talk about one more thing. When do we need to use for ratio tests? Ratio tests usually involve with something that says something to the a to the n power, or n to the n power, or n factorial. Those are the situation I will for sure use a ratio test, because those are the cases that it's kind of hard to compare, and it's kind of hard to take a derivative, right? So, and so that's the situation. So in this case, I'm gonna start by plugging this, and a lot of people get confused. So we're gonna make sure limit n approach infinity, and we're gonna do absolute value. In this case, it's not gonna impact, but it's n plus 1 square. Does that make sense? Times 2 to the n plus 2, because n plus 1 plus 1, over 3 to the n plus 1, all over n square, times 2 to the n plus 1, all over 3 to the n. Any questions here? So now this is equal to limits n approach infinity, n plus 1 square times 2 to the n times 2 to the 2. Is that okay? Over 3 to the n times 3. Is that okay? I just break that exponent up. Times by 3 to the n over n square times 2 to the n plus 1, which is 2 to the n plus 1 is 2 to the n times 2. So now I'm going to go in slowly, cancel things out. And what else I can cancel out? 2. What?
Also, you can
Oh, that's why it's this one's.
you can make 2 to 2.
And this one can cancel out. Yeah, my,
You can cancel out the 2 square just to make it 4. With
and
the
that's gonna be
11.
2. So yeah, so this one's gonna be equal to limits as n approach infinity. You got n plus 1 square over n square times 2 over 3. Now for this, remember they both to the second power. You can put in 1 parenthesis. And if you approach infinity, this becomes 1 square times 2 over 3. And that becomes equal to 2 over 3, which is less than 1, which is converge. Does that make sense? Yeah, it's really bad. I cancel 2 to the n and 3 to the n. You can see my brain is not really working.
Yeah, I think you need a bed in your bathroom.
Yeah, instead of ping pong every day, every time you can, you should like go take a nap.
That's a good idea.
From my soccer coach used to do last year.
Really?
Before the games, you guys were tired during his lunch period. He just sleep in the back room.
Oh. Does he have a bed over there? Alright.
You think I got
I'll get a couch, yeah.
Like algebra back there.
I just love
That way, if like Brandon's wiped out, he's not learning any calculus, you can just like go back there.
Go
That way
to
you
the
don't
class.
have to see Brandon's face.
Go to the class. Yes. Aiden?
Is the next one inconclusive?
Next one is inconclusive, but this one's kind of hard to tell. And the reason why it's kind of hard to tell because we got n factorial now, but this is something else though. This is a summation. Bennett, I cannot talk over you.
Sorry.
So n equal to 1, infinity, n to the n plus 1 over n plus 1 factorial.
So I think we should make
Yes,
it
you
n
do.
plus 1 to the n plus 1.
Yeah.
Yes, you do. You're right. M plus 1 to the n. That is m plus 1 to the n plus 1 over m plus 1 factorial. Is that okay? Limits n approach infinity. Absolute value of this, since this doesn't have impact by absolute value, you don't have to worry about it. N squared over n factorial. Thank you, McKenna. So this is limit n approach into infinity. This one's m plus 1. And then to the n times m plus 1. Is that okay? Because that's that. And this is m plus 1. Now since it's factorial, I'm gonna break down because I want to cancel the m factorial. So I'm gonna change that to m factorial. Divide n to the m factorial over n to the n, and that's what I'm talking about. This one will actually cancel out. N plus 1 will cancel out. We're left with limit n approach infinity of m plus 1 over n to the n power. And then you say, okay, what does that mean? This is actually a definition that you guys probably not able to recall because it doesn't look exactly the same. But we can definitely split them. Yep. So this is a definition of E.
Oh, my brother was asking me this yesterday. He was asking me if we learned
E.
like as x approaches e or something like that. Definition of E.
Wait, it's just E by itself.
Yeah, so E is a greater than 1.
It's the number.
Oh.
So basically, if you plug in infinity for this, it's up 200.
It goes to E.
Oh, shall we?
Converges to E.
Yeah, so if you don't believe me, right, let's go to Desmos. That says as 1
It goes to E.
you look at when x could approach infinity, what happened? No. No, it's converged. We're just talking about function. When they go to infinity, it's 2.68.
Or Mr. Yeah, can you just put like x is equal to, or y is equal to E?
But isn't E
Okay,
driven
x equal to, let's say, 1,000. I think that's better. Okay, so that will give you 2.718, which is the E. So that's the definition of E, and we learned that before. So that's E is greater than 1 is diverge. Is that okay? Now, there are sometimes you're going to have a failed test. So this one is a failed test. So if it's a failed test, this one we're going to do limits as n approach infinity. Again, this is a big ratio, so be -1 to the n plus 1 times square root n plus 1 over n plus 2. Is that okay? -1 to the n square root n over n plus 1. After absolute value, this completely goes away because absolute value. This becomes n plus 1 over n plus 2 times by square root n n plus 1. And this, if you go to infinity, it will actually end up to be 1. So you have to use alternative series test here because this is alternating. I don't have time, but it will end up to be converged. Because you had to take a derivative to test the decreasing. If you do that,
Why would you not just start with in a series of shot? Why would you start with ratio?
exactly, it's because I want to give you an example. I will start with you're right, I will start with that because this one's not n to the n or n factorial. I would definitely start with the n alternating, but just to show you that there's a case where it's equal to 1. Just because this is a kind of important test, and I don't want to put all together.
And if it was just I'd be like, oh, square root of -1, I can do that. And then
Like I need those extra 10 minutes.
Yeah, five different ones. I thought it was really big. So it's like I didn't know. I think I'm
If your headache is that bad, I'm just saying you take it. It's not gonna get better.
No, I already take Avio, 2 Avio in the morning at 6 o'clock.
6 o'clock?
Yeah, so I have to wait for like 6 hours.
It's been 6 hours. Not about time. Do we have homework?
Yeah.
Okay. Can you send it, please?
Yeah.
Bob was asking for it. I'm pretty sure we're all just gonna do it. So. See you later.
grow up on I can probably I think you guys did not. You don't know how to use headphones? What's up on your ear? Yeah, but how do you Bluetooth? How do you use Bluetooth?
There is no
I ran out of paper. I ran out of paper. I have to go.
Arthur, you're
I
honestly
ran
my
out of
favorite.
paper. I didn't have any more to write. They need to be moaning about me not doing 39.
Let's be right now.
Isn't the linebacker usually like
Alright, those are people that constantly talking, I'm talking. Especially people like Nyla, don't have to worry about it. Few other people, I don't know who are. But I will tell you, like right now, I have a huge headache. I have a pill right in front of me. It's 800 milligram ibuprofen. I'm thinking about swallowing that like, right away. I probably should, but I haven't. So that means at some point, if you piss me off, I will curse you off. And like I say, I have cursed people off last week. So I would just say shut the fuck up. But just let you know, like I'm not in the right temper to deal with nonsense. So at least not today. Well, there was one of them.
Did my homework.
Ayla, especially you. Not in the right temper to deal with you today. So like I said, I have a huge headache, and just want to get this thing done. We want to try to finish and solve trig equations. If you have any question, just raise your hand. Don't ask each other. Ask me. So at least I can answer everybody at some time. I don't want to go through it. So right now, first 5 minutes, I want you to go through homework and make sure you check it while I'm taking homework. And try to make sure you understand everything. And also you can check your answers, see how your answers. Sometimes you work at, let's say 2 sine of x minus 3 equal to 0, and you got a sine of x equal to 3 over 2. Sine of x cannot equal 3 over 2 because they are oscillation between -1 to 1, and so they are not gonna be so let me know you.
No, I left it in the schools because I did my homework here.
I saw you on yesterday. So spend 5 minutes to go over it, and now we're going to talk about whatever is today, so we don't try to finish it up today.
I'm getting 7 times so I have to do that. Can you read it?
For the first one, I'm just gonna go pay the y'all get.
Might not do it like
I think it's all down. That's how I got that. That's why I got it wrong. It's not that equals 2 pi because you go.
Oh yeah.
I forgot that.
But I put the first one, it was kind of complicated. And it was just like the plus one. So I got an Oh,
I still don't know how I can. You look like you're having a job. Math. You did
yeah, I did. That's what it's like.
did you do different
I did the
Oh, you know. No, I got three of it. I don't think back to that.
No, wait. Oh.
Yeah, and then once you find out that it's root 3, kind of like, if it's root 3, that's if it's root 3,
That's 3, 5, or 2. I don't know where.
yeah, you can do that.
Yeah, that'd be negative. 10x equals negative. Wait. I forgot to because it's
Oh, I see what you're talking. Yeah.
Oh wait.
Yeah.
Y equals negative 1. Why? Yeah. No, because I just think it's wait, how do you get 2 pi?
I did that.
From negative 1 point to negative 1.
So this is your circle. Zero's right here. You do half the rotation to get the top.
Okay.
You know, if you do a full rotation. So right here,
Oh, yeah.
it's in between pi and 2 pi.
So y'all converted it into
3 pi.
Yeah.
Yeah.
Okay. Oh, okay.
there.
That's a question.